Let's look at a couple of problems involving square roots of negative numbers. There's a couple of ways that it's easy to make mistakes with these kinds of problems, especially in ones like this first one, this guy right here. So when you're multiplying or looking at a fraction of two square roots of negative numbers, there's a certain mistake that's very easy to make. So if you have something like square root of 2 times square root of 5, something like this. And both your square roots, what's underneath them, it's called the radicand. So both of those radicands are positive. There's a property that you can write this as a single square root, and you just multiply those two radicands. 2 times 5 is 10. And that's totally fine. This only works when you have positive numbers under your square roots. Because it only works for real numbers. As soon as you make these negative, now these are not real numbers and you don't have this property. So what we're going to see actually is that when they're both negative, you end up with a negative answer. But let's see how that actually works. So I'm going to get rid of this stuff. Okay, here we go. And let's look at this first problem. Square root of negative 12 times the square root of 18. So what we want to do is at the least deal with the square root of negative 1. At least think of each of these as something like square root of negative 1 times 12. And bring square root of negative 1 out of the square root and write I outside the square root symbol. And let's go ahead though and simplify this as much as possible. So 12 actually does have a perfect square factor, 4. So we can write the square root of negative 12 as square root of negative 1 times 4 times 3. And then we can take the square root of each of these 3 individually. If you want, you can even write that out as 3 separate square roots if you're not real confident with simplifying square roots yet. So we'll have I times 2 times square root of 3. Actually, let me just make that square root of 3. We don't need an extra multiplication symbol. Okay, and then same kind of thing with square root of negative 18. And 18 happens to have a perfect square factor as well, and it's 9. So let's write that this is the square root of negative 1 times 9 times 2. And again, if you want to, you could write this as 3 separate square roots. You may feel comfortable enough, though, going ahead and skipping to just writing out what you get. So square root of negative 1 is I, square root of 9 is 3, and then square root of 2. So now we're going to multiply the stuff outside the square root together and multiply the stuff inside the square root together, because now we have the stuff with the square roots. These are real numbers, right? So we're taking the square roots of positive numbers. So now we can use that little formula that we were talking about. Okay, so the i's are going to multiply together. So we're going to have an I squared. And then 2 and 3 are going to multiply together. 2 times 3 is 6. And then underneath our square root, we can do 3 times 2 is also 6. And so finally, I squared is negative 1. So we get negative 6 root 6 for our final answer. So when you have square root of a negative number times square root of a negative number, it pretty much, it's going to multiply out and you're going to have a negative whatever your final answer is. So let's see what happens if we have square roots of negative numbers, but we're adding or subtracting. So over here, we're subtracting. And whenever you're adding or subtracting, you need like terms, or in this case, that means like radicals. So whatever's under your, in this case, square root, you need it to be the same in order to actually do the subtraction. So let's simplify and see what we have. May or may not work out that we get the same thing left under our square root. Okay, so this 6 is going to hang out. and square root of negative 20. Well, definitely we can deal with the negative 1. Square root of negative 1 is I. And then 20 has a perfect square factor of 4. So we can think of this, I'm actually going to think of this as just negative 4 times 5. So then, oops, the 6 is sort of hanging out. I'm going to take the square root of negative 4 is 2i. 6 is being multiplied by this, so 6 multiplied by 2i. And then square root of 5 just has to stay square root of 5. And then we can go ahead and multiply 6 and 2, and we get 12i root 5. So now let's do that same process with the negative 2 square root of negative 45. Okay, so same kind of a thing. Negative 45, I'm going to think of this as, well, 45 has a perfect square factor of 9, so negative 9 times 5. I didn't mean for these to have the same perfect square factors as the previous problem. So negative 2 hangs out. Square root of negative 9 is 3i. And then we're going to do square root of 5, right? Because we can't simplify that square root of 5 any further. And negative 2 times 3 is negative 6. So negative 6i root 5. So bringing it back into one problem, we have the 12i root 5 minus 6i times the square root of 5. And now we have like terms or like radicals. Both of these terms have an I and both of them have square root of 5. So we can think of the 12 and the 6 as being our coefficients that we're going to do the subtraction with. 12 minus 6 is 6. So we get 6i times the square root of 5. So for any of these problems where you have square roots of negative numbers floating around, just simplify them first, and in particular, bring square root of negative 1 out as I.